identified an appropriate location, we then make plans to drill a well. This is the only sure way to find out if there are hydrocarbons present. Construction of any well will follow a series of defined steps, although the steps may vary slightly depending on the type of well being drilled. Exploration wells, or wildcats, as they are sometimes known, are drilled to confirm the presence of hydrocarbons. Appraisal wells are drilled to discover the extent of the oil or gas field. Development wells are drilled to produce the oil or gas that has been discovered after the exploration and appraisal wells have been drilled. In this module, we will go through the complete life cycle of a development well, from initial drilling to abandonment. Searching for oil or gas is not so very different from digging a hole in the ground. Imagine you begin to dig, and keep on digging, and digging, and digging. When you reach a certain depth, there is a risk that the walls will cave in. This could pose a danger to life or the environment, and the hole will also be lost. Naturally, we must prevent this from happening, and we can do this by supporting the wall of the hole. In this case, we have placed a piece of pipe in the hole, but in the oil field this is called casing. This first casing will typically be up to 30 inches in diameter, as it will need to be big enough to allow all the other different sized casings, which may need to be used as the hole gets deeper, to pass through it. This piece of casing will often pass through natural groundwater courses, or aquifers, that can run close to ground level. On its own, the casing is unable to isolate the well from these groundwater supplies, so we usually have to cement it in place. We will take a closer look at this process later on. Now that the casing is in the ground and firmly cemented in place, we can continue digging for hydrocarbons safely. Before we start digging, or drilling in oilfield terms, we need a drilling rig. This is a collection of complex machinery that is used to drill through the earth to reach the hydrocarbons. Although drilling rigs come in many different forms, they all have to do the same job: to support heavy weights and rotate the drill bit. We will study drilling rigs and the people that work on them in later modules, but for now, let's focus on the drill bit. When using an electric drill at home, you must select the drill bit you need for the job you're doing. For instance, if you tried to drill brick with a wood bit, you would just blunt the bit and hardly make any impression on the brick. The same principle applies when drilling a well. The drill bit is attached at the extreme end or bottom of the drill string. The drill string is another name for the many short lengths, or joints, of drill pipe that are joined together as the hole gets deeper. Each section of drill pipe is typically 30 feet long and joined together by threaded connections at each end, which allow the sections to screw into each other. There is a range of other equipment that is also added to the drill string. We will look at these in later modules. So, how does the drill bit work? Quite simply, it crushes and grinds up the rocks as it goes deeper and deeper into the earth. These crushed up pieces of rock are called cuttings. The type of drill bit used is dependent on the type of rock that is being drilled through. A tricone bit has a set of 3 rotating cones with teeth or inserts which crush the formation, allowing the mud to remove the cuttings. They can be used in soft or hard formations, depending on the teeth or inserts used. Polycrystalline diamond compacts, or PDC bits, have cutters which shear the rock with a continuous scraping motion. They are designed primarily for formations such as shale. A diamond bit uses industrial-grade diamonds to simply grind away the formation. They are designed for very hard formations. If the cuttings were to remain in the hole, they would jam up the drill bit and make the drill string drag on the well bore, which is what we call the hole that has been drilled. This means that the cuttings have to be brought to the surface. The cuttings are carried to the surface using a blend of liquids and additives called drilling fluid or mud. The mud is mixed and taken from mud tanks, pits, before being pumped down the drill string. It exits the drill string through holes or jets situated in the drill bit. The mud then returns to the surface via the space between the outside of the drill string and the open hole or casing. This space is called the annulus. The mud is returned to the mud pits through a return pipe attached to the top of the 30-inch casing once all the cuttings have been filtered and separated out. The mud performs several other important jobs besides carrying the cuttings up the well. Mud cools the drill bit as it drills through the earth and, most importantly, the weight of the entire column of mud is used to hold back the pressure contained in the different layers of rock and in the reservoir. The pressure created by the weight of all the mud in the hole is designed to stop formation fluids flowing into the well. If this is not contained, it could result in a blowout.